In this video, I'm going to go through the equations of circles second review packet. So for number 1, which of the following equations describes the circle shown graphed below? Well, to write the equation of a circle, remember that's x minus h squared plus y minus k squared equals the radius squared. And we need to know two pieces of information. The coordinates h comma k are going to represent the center, and r is going to represent the radius. So if I can identify those two things, I'm good to go. If I'm looking to see where the center of the circle is, it looks like the best coordinate for that would be -2, 3. And if I count 1, 2, 3, 4, 5 in any direction from my circle center, I can see that all the points on the edge of the circle are 6 units away, whether I count to the right, up, down, or left. So that tells me I picked the right center and that the radius is 6. So when I substitute into this formula right here, x minus the h coordinate, which is -2, but notice when I subtract a -2, it should become positive, plus y minus k, which is 3, equals r squared, and the radius squared is just 36. So the one that fits there is answer choice 1. For number 2, a circle has a center at 5, 2. If the point 8, 6 lies on the circle, then which of the following would be the slope of the tangent line drawn at this point? Well, I'm just going to sketch a picture here. I've got a center, let's say that's at 5, 2, and a point somewhere on the edge of the circle at 8, 6. If I want the slope of the tangent line, the problem is I only know one point on the line. I need to know 2 points to find a slope. But what I could do is I could find the slope of the radius and then take the negative reciprocal because I know it'll be perpendicular to my tangent line. So I'm going to start by finding the slope of the radius by plugging into the slope formula. That's y2 minus y1 over x2 minus x1. So I could label one of my points as x1, y1 and my other point as x2, y2. It doesn't matter which one you label as which as long as you're consistent. So y2 is 6 minus y1 is 2, divided by x2 minus x1. If I simplify this in the numerator, I get 4, and in the denominator, I get 3. So this is the slope of the radius, but the slope of a line perpendicular to that would have a negative reciprocal slope. So that means flip the fraction, put 3 in the top, 4 in the bottom, and change the sign. So my original slope is positive, so the negative reciprocal slope should be negative. So the answer choice that fits there is answer choice 2. Number 3. A circle has a center at point -2, 5. If the point 4, 2 lies in the circle, which of the following is closest to the length of the radius? So all I have to do for this one, if I know the center and the point on the edge, is I can plug into the distance formula to find the length of the radius and then just round my answer in my calculator. So remember the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Again, I'm going to label one of my points as x1, y1 and x2, y2. So the distance here is the square root of 4 plus 2 squared, because I'm subtracting a -2, plus y2, which is 2, minus y1, which is 5. So normally I type all that under the radical in first to show that I don't have a perfect square under the radical. But when I type in radical 45 into my calculator, the decimal equivalent is about 6.7. So that's about the length of the radius there. If I needed to find the diameter, I would just double that. Number 4. The circle x minus 5 squared plus y plus 3 squared equals 245 passes through that point right there. What is the slope of the line segment that connects the center to point A? Well, I still need to identify the center here. The center just has the coordinates 5, -3. Again, I'm just looking at the opposite signs of what I see there. And the point A is at 19, 4. Again, if I want to find the slope, remember that's the change in y over the change in x. So, slope, in this case, I'll make my center x1, y1, and my point A x2, y2. Again, it doesn't matter which one you choose as which. So if I plug into the formula y2 minus y1, again, that's going to become plus when I subtract the negative 3, over x2 minus x1. 4 plus 3 is 7, 19 minus 5 is 14, and if I divide the top and bottom by 7 to reduce it, I find the slope of this radius is 1/2. Now for part B, it asks me to write the equation of the tangent line at A. Well, remember the tangent line and the radius are going to be perpendicular. So the slope perpendicular to a line that has a slope of 1/2 should be the negative reciprocal, which is negative 2 over 1, or just negative 2. And if that's the slope, and I know one point that's on the line, 19, 4, I can plug into point slope form, which is y minus y1 equals my slope times x minus x1. I'm going to start making my substitution. So y stays as y, minus my y-coordinate of the point on the line is 4, my slope is negative 2, x stays as x, and my x-coordinate that's on the line is 19. So that represents the equation of my tangent line because it has a negative reciprocal slope to my radius, and it passes through the point 4, 19. Now in order to find the y-intercept of this line, I'm just going to want to isolate y so that I could write this in slope-intercept form. I'm going to start by distributing the 2 into my parentheses there. So I still have y minus 4, negative 2 times x is negative 2x, and a negative 2 times negative 19 is just positive 38. Now I'd want to do a minus 4. I could add 4 on both sides to find the y equals negative 2x plus 42. So my y-intercept here is just going to be 42, because that's the plus b part for slope-intercept form. Number 5. A circle has that equation. Determine the coordinates of the center of the circle. So this is going to be one of those completing the square problems, and I could tell because it's not in standard form showing me the center and the radius. So I'm going to rewrite this formula as x squared plus 10x plus blank plus y squared minus 2y plus blank equals 266 plus blank plus blank. Because if I'm adding two different things to the left-hand side, I should add the same number of things to the right-hand side. What you do to one side of the equation, you must do to the other. Now here's the completing the square part. I'm going to take the number next to x, that 10. I'm going to take half of it and square it. Half of 10 is 5, 5 squared is 25. So I'm going to add that to the left-hand side here, but I'm also going to add that to the right-hand side. I'm going to do the same thing with this minus 2 next to the y. Half of negative 2 is negative 1, and when I square that, I get positive 1. So I'm going to add 1 there and add 1 there. Now here comes the factoring step. You could factor each of these trinomials because you've created perfect square trinomials here. So if I just look at x squared plus 10x plus 25, I could ask myself what numbers add to positive 10 and multiply to positive 25. And if I do that work off to the side here, well, I know 5 times 5 is 25, and 5 plus 5 is 10. So if I write my double bubble, x and x, the two integers that are going to go there are positive 5 and positive 5. Now this should happen every time, right? Because the whole idea is we want to factor this into something squared. So x plus 5 times x plus 5 can be rewritten. And if you want a quick trick, you could just look at your b term there and take half of it. Half of positive 10 is positive 5. That trick is going to work every time if you want to save yourself some hassle for factoring. So similarly, two numbers that multiply to 1 but add to negative 2 are going to be minus 1 and minus 1. But again, if you want to take the quick shortcut, half of negative 2 is negative 1. So that might help you out a little bit there. And if I combine my like terms on the right-hand side, it just equals 292. So part A said determine the coordinates of the center. So if I'm looking at the plus 5, that tells me the x-coordinate for my center should be negative 5, and then minus 1 tells me the y-coordinate should be positive 1. So those are the coordinates of my center. Part B says the point 11, 8 lies on the circle. write an equation for the line tangent to the circle at that point. Well, this is the same scenario as the last problem, where I know the center, and I know some point on the edge of the circle. That should be 11, 7. So I know one point that's on the line, but I still need the slope of the line. So what I'm going to do is I'm going to find the slope of the radius there by plugging into the slope formula, and then just taking the negative reciprocal because I know they're perpendicular. So the slope formula one more time is y2 minus y1 over x2 minus x1. So my slope is, let's say if I organize my work a little bit better here, let's say I've got negative 5, 1 as x1, y1, and 11, 7 as x2, y2. So y2 is 7 minus y1, which is 1, over x2, which is 11, minus negative 5, but again, that's just going to be plus 5 when I subtract the negative. So in the numerator, I get, let's see what I get here. I get 6, and in the denominator, I get 16. If I divide them both by 2, I find that slope is 3/8. So that's the slope of the pink line right there, that radius. But to get the slope of the tangent line, I need the negative reciprocal of that. So the negative reciprocal is going to be negative 8 over 3. And the point that the line definitely goes through is 11, 7. So if I know a slope and a point, I can always plug in a point-slope form. Y minus y1 equals my slope, m, times x minus x1. Y minus, the y-coordinate of the point is 7, the slope is negative 8/3, and the x-coordinate of the point is 11. So you don't need to solve for y, that's as far as you need to go. That represents the equation of a line tangent to the circle at 11, 7. Number 6. The endpoints of a circle's diameter are negative 1, 2, and 9, 2. Use the midpoint formula to determine the coordinates of the circle's center. Well, you got to visualize this. If I've got a circle, right, and I've got two endpoints of the diameter and connect them, a diameter has to pass through the center, so the center should be equidistant from either of those points. So that's why the midpoint formula helps us here. Remember, the midpoint formula is just the average of the x's, x1 plus x2 over 2, comma the average of the y's. So I'm adding my x's dividing by 2, and I'm adding my y's dividing by 2. So when I substitute in here, negative 1 plus 9 over 2, comma 2 plus 2 over 2, that just simplifies to 4, comma 2. So that represents the coordinates of my center. Part B asks me to use the distance formula to find the length of the radius. Well, think about if I know the center, and I know I've got a point negative 1, comma 2 over here, and a point 9, comma 2 over here. This distance in pink represents the radius, but also this distance over here represents the radius. So it doesn't matter which of the endpoints I use, as long as when I'm using the distance formula, at least one of my points is the center. So I'm going to choose negative 1, comma 2, but it doesn't matter which endpoint you use. So remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So the distance is equal to negative 1 minus 4 squared plus 2 minus 2 squared. Or if I substitute that into my calculator, I find that the radius is radical 25, or just 5. So if I want to write the equation of a circle for part C, that's x minus h squared plus y minus k squared equals my radius squared, I know all of my information. I have my h comma k, and I have my r. So x minus the x-coordinate of my circle, which is 4, plus y minus the y-coordinate of my center, which is 2, equals the radius squared, so 5 squared is 25. That would be the standard form equation of my circle with those endpoints of a diameter. Now, in order to show that any given point lies on the circle, that means that when I plug into the equation of the circle, it should satisfy that equation. So I'm going to plug in 8 for x, and I'm going to substitute in 5 for y. and I want to see if the left-hand side equals 25. Well, 8 minus 4 is 4, and 4 squared is 16. 5 minus 2 is 3, and 3 squared is 9. And when I add 16 to 9, I get 25. So this would show that, in fact, the point does lie on the circle, because when I plug it in for x and y, it satisfies that equation. Number 7. Solve the system of equations below graphically. So I'm going to start by recognizing that this is a circle with a center at 3, -1, and a radius of the square root of 25, which is just 5. So I'm going to go to 3, -1, plot that point, and I'm going to plot 4 nice points on my circle. I'm going to go up 5, I'm going to go right 5, 1, 2, 3, 4, 5, down 5, and left 5. And I'm going to connect those the best I can. It doesn't need to be perfect, and mine won't be here, but that's okay. Right? Just to give you the idea, I'm doing this kind of fast. Alright, so let's say that's the circle. I'll do that point a little bit better, curve it nicely. And this represents the equation of a line in point-slope form. I recognize that as y minus y1 equals my slope times x minus x1. So that's telling me that my slope is up 3 over 4, change in y over change in x. And a point that's on the line would be, that x-coordinate should be -5, and that x-coordinate should be -7, because if I were to substitute those back into point-slope form, that is the equation I would get. So to graph this line, I'm going to go to -5, -7, and I'm going to apply my slope from there. I'm going to go up 3, 1, 2, 3, over 4, 1, 2, 3, 4. Up 3, 1, 2, 3, right 4. Up 3, 1, 2, 3, right 4, 1, 2, 3, 4. And I'm going to just connect those with a straight edge every time I draw on a line. That's the line y plus 7 equals 3/4 x plus 5. And my solution to those systems of equations would be the points where they intersect. So it looks to me like one good point of intersection would be at -1, -4, and the other solution would be at 7, 2, where that circle intersects the line at 2 points. So this is not a secant line, this is not a tangent line, but it's a secant line because it intersects my circle twice.